newborns. We have population data because the information provided is based on birth and death certificates. So for every event in the US in the year 2015. We have two graphs. So let's look at each one of them and make sure we understand them. The first one says it represents birth weight of newborns. And we have on the horizontal axis birth weight in kilograms, so quantitative variable. And the vertical axis shows count, so how many newborns. Notice that there is no reference to any other variable in this graph. So we have the representation of one variable, quantitative. This is simply a histogram. The tallest column is for the interval 3 to 3.5 kilogram as a birth weight, and it corresponds to a height of nearly 1.6 million. So this tells us that in the US in 2015, there were nearly 1.6 million newborns with a birth weight of somewhere between 3 and 3.5 kilogram. So how do we describe the distribution of birth weights here? Well, we see that the birth weights range from the tiniest, less than half a kilogram, to more than 5 kilograms. The distribution is slightly left skewed because we can see that it is single peaked, but the peak is not quite in the center of the range. Most of the birth weights were between 2.5 and let's say 4 kilograms, and the peak was for the 3 to 3.5 kilogram. Now, in the second graph, it tells us that it shows the percent of newborns who died within 1 month for each birth weight group. So you will notice here that there's mention of two things: dying within 1 month and birth weight group. On the horizontal axis, we have birth weight in kilograms, and on the vertical axis, percent. Now, the percent is for the categorical variable yes or no, died within 1 month. What is not shown here is the percent that did not die. So, for example, for the first birth weight group at less than half a kilo, we see that roughly 95% of those very, very small newborns died within 1 month. The remaining roughly 5% survived at least the first month. Now, you want to make sure that this interpretation is consistent with the rest of the graph. In the next birth weights, so for newborns that weighed between half a kilo and 1 kilo at birth, about 25% of them died within 1 month, meaning the remaining 75% did not die. They survived the first month. Notice that in particular, if you add up all the columns in that second graph, they would add up to more than 100%, which clearly is not compatible with the incorrect interpretation that this is just a distribution of birth weights for the newborns who died. What this graph is a bar graph of the categorical variable died within 1 month of birth or did not die within 1 month of birth for different birth weight groups. We cannot talk about skew or symmetry here because this is not a histogram. So what do we make of that second graph? Well, what it tells us is that the death rate was highest for the smallest babies, and it was extremely, extremely high for those newborns that were very, very small, less than half a kilogram. And thankfully for heavier babies, the death rate is much, much smaller. Now, we were asked whether it would be correct, based on the data provided here, to say that most newborns who died within 1 month had a very small birth weight, less than 1 kilogram. So let's think about that. The question is asking what percent of the newborns that died had a very low birth weight, less than 1 kilogram? And is that most? So is that more than 50%? Well, we don't know that because, again, the second graph is not a histogram. You might think, well, for the smallest newborns, it's a 95% death rate. And for the next smallest group, it's a roughly 25% death rate. So surely most infants that died must have been very small. Well, the fact is there were very, very few tiny newborns. And we know that from the first graph. So a large proportion of something small is still something quite small. Now, on the other hand, we have the millions, plural, of newborns with a nice healthy weight, but a tiny, tiny percent of them not surviving at 1 month. So now you have to consider which is going to be bigger, a large fraction of a small amount or a tiny fraction of a large amount. We cannot say that it's obvious that most newborns who died were very small newborns.